Have any more presentations, right?
No, so you guys, I will let the audience do any announcements while you guys set up. Are there any announcements from anybody? Member announcements while these guys set up for the panel? No? Ministream is also hiring. Might as well throw up.
We're early, so that's good. Well, yeah, you both through.
So how many seats do we need in the back? I see some people standing. Is that by choice or by lack of seats?
We have some up here.
I've done a bunch of these things. I always get every time I.
And we can also grab a couple more chairs if necessary.
It's pretty good. Don't go so just get up. Sit down. Find me. Yeah. Yeah, that's why. Yeah, just don't know. I think you're good. I want to do it. This is like a
Yeah, I can stand. Okay, so I guess we can start with the panel discussion. Thank you so much again for agreeing to be kind of queried here. I'll start with some general questions. And I'll just pass the mic around, and I just was told that we need to make sure to keep it close to our mouths since people in the back otherwise have trouble hearing us.
I'm sorry.
So it's visual, right? So it doesn't really need many words. So I guess I'll start with Fazad first, and then I'll kind of randomize the order. So the first question is, what is the key differentiator of your solution within the big data ecosystem? We already saw some examples in your presentations, but if you could just succinctly say it one more time, I guess.
Sure. Quick sound check. Can you hear me okay in the back? All right, perfect. I think for us, time, right? So the company was founded 2 years ago. When we started the company, we actually weren't thinking about getting into the BI space. We actually wanted to bypass sort of like what we call the BI turf warfare. And what we focused the company on initially was real-time visualizations on mobile devices. So actually the first version of our application was an iPad app, and it focused on streaming data and streaming visualization. So that really forced us to kind of have to embrace not just the traditional SQL world, but look at NoSQL and streaming services. On the mobile, we had to really think about user experience, so no right-clicking, making sure the interface was responsive, making sure that the icons, etc., can fit the radius of the finger. And then on the visualization, really trying to take advantage of things that are good for motion, because you're looking at streaming stuff. But then as we started kind of taking this to the market, we wanted to kind of, we all come from a heavy enterprise background. We thought we wanted to go after the consumer space. But then as we started taking this to the market early on, just got a lot of feedback about, okay, we're, with companies, enterprise side, there was a lot of pain points around these new use cases, new emerging use cases where people were starting to look at Hadoop. At that time, Impala was sort of like closed beta. We're looking at NoSQL and search sources. So then we kind of got pulled back in, I guess, to the turf warfare around kind of just data visualization and wanting to interact with it. And again, not keeping it focused on data scientists or developers, but more on the business user community. So I think from a differentiation, just given that background, and what we kind of evolved it to was on the connectivity side, we went ahead and kind of embraced not just SQL, but we support natively NoSQL as well as search. And then I think from an interface, we made it responsive with 100% web footprint, wanting to have that ability to kind of translate the experience across different devices. And that specifically around touch, so tablet sizes and up. And then on the data visualization, embracing the D3 and the JavaScript stuff, there's a lot we learned about what it takes to make it performant, and lots of great things that came out of that. But again, embracing sort of that movement around it. And then once Impala came out in the Cloud Era Search, Spark started getting traction. So again, having the ability to kind of embrace that and bring that into our architecture. So I think in general, we have sort of the same ambitions as the existing sort of players, and the existing functionalities, but wanting to kind of rethink it given the technology advancements.
So Platfora has a kind of a different view of the world. So we started as a big data company. So we wanted to make big data approachable by non-technical analysts, right? I've been using Hadoop now since I think 2007. So and it's really, really hard for a business analyst to really get access to that data in Hadoop. So the initial vision of the company was, how do we make the data that's living in HDFS today presentable and approachable by a non-technical analyst? I don't want to have to train 1,000 people to write MapReduce or now Spark, right? So as the company's vision kind of evolved, we got to this point where we wanted to provide a end-to-end workflow from raw data living in Hadoop to business intelligence type visualizations that allowed for not just your traditional structured sources, but something we call multi-structured data. So being able to incorporate not just your Excel spreadsheets and your CSV files, but also your JSON nested objects or data directly from completely unstructured text from off the web or something like that. And allow all of your users, your data scientists, your data administrators, your business analysts, your executives, to all kind of collaborate in the same tool and have access to the same data and not have to jump through 10 different products with 10 different pieces of context switching to answer any particular question. And one of the things that we found when we really started digging into building the product in a way that was going to allow for this workflow to be collaborative and iterative and agile was that we were able to shorten the window from raw data to actionable insight from, in a lot of cases, days or weeks, sometimes even months. I was an ETL developer. That's when I started using Hadoop, and it would take us, weeks and weeks to get a new data mart out to an analyst. And with Platfora, we're talking, a few minutes to an hour maybe to get a new data mart out to an analyst. Now, the quality of the data mart might be a little bit different, right? So the data mart might not answer all of the same questions that they would if I started, I spent 2 weeks doing data modeling before I got started. But now instead of having, a long-running ETL job that I've got to run over the weekend, and so it only gets refreshed once a week, we're presenting this interface that allows the analyst to say, hey, my data mart, I really need to add age for, say, that names demo that Tableau was doing a little bit earlier. Maybe I need to add age and it's not in my structured data source. Well, but it's in the raw file. So because of the way we've architected the system, it allows the analyst to say, oh, I know that I just need to add age to my data mart, click in a couple of spots, click on build. It goes off, it tasks Hadoop with MapReduce and Spark to build my new data mart, and it tells me when it's ready, and then I can start interactively iterating over my data all over again. But the thing that I have found, it's a super powerful thing, because you go from having the 3 or 4 or 5 different people involved in the process of answering a net new question that I just thought of today, which can be a really costly enterprise, to getting to a point where, because the system is collaborative and everybody's working in the same spot and all the metadata is there and everything like that, a business analyst, in a lot of cases, can request a brand new data mart with a completely different set of data that nobody's ever looked at before, and answer a question with that data mart without any other interaction other than with the system. They don't have to call an ETL developer. They don't have to call a data scientist. They can click on a couple of buttons, request their new mart, visualize that data, understand it, and then publish it out to their boss via PDF, or share what we call our dashboards, Visboards, with someone else in their community. They can comment on it, take screenshots, all that kind of stuff.
Thank you. I think coming from my perspective within a lab prototype environment, the customizability of using mostly open source tools is what's really huge for us. And I know that differs a lot when you get in this environment where we're building tools for business analysts as well. From what I see the most, the projects that we encounter, really we don't have a platform we're working with. Really our platform is we have data, and it's probably sitting in Hadoop, and we have an end goal that we want to meet. And probably every time we have a new project that spins up, there's a new dimension that's probably the most important. Sometimes it's the speed at which you're accessing data. So maybe you're building a project related around fraud where milliseconds matter, versus something else that's being built for an end user or someone in a call center or something along those lines, where you have very detailed, specific requirements on the visualization side, where speed is not quite as important. Maybe you're not running in batch mode, but you're talking in terms of minutes or hours. But the ultimate visualization you're building is so specific that having complete control over what you're doing, where you're actually you have devoted resources, software developers writing this from the ground up. And there can definitely be downsides to that as well, but there's also really big advantages. And the more I learn about this, I think it's always kind of an ongoing struggle to learn this. You're seeing how other companies do this. It's not even as much as saying, we need a NoSQL database or something. You really start digging into it, and you see each one of those tools has a very specific requirement for how you can use it, and it has advantages over other ones that might define this particular architecture. We're going to use Cassandra versus HBase versus Memcached or something. And this we're going to use Spark streaming, or maybe it doesn't exactly meet the requirement we have, so we're going to use Storm. So I think each piece you can kind of start at the what your original data is, and then eventually your vision for what your product is, and you can just start picking out these technologies, and you have multiple options on how you want to construct this thing as you go up. And luckily, the thing that's great as a developer, obviously, is everything. If it's open source, you can not only tweak it, but there's a large community building these things out for you. And so you probably pick maybe two or three of the pieces you want in your architecture that maybe you're most comfortable with. And most likely there's going to be plenty of other people who've written connectors. And so if I want to get data out of Socket.io into, from Mongo into, I'm definitely not an expert on each part of those pieces, but you can just Google it and pretty much find enough either GitHub repositories or documentation on how to sew all these pieces together to get you something that's functional. And then if you get new requirements and I'm like, okay, Spark streaming is not really, it's in batch mode, I really need something that's truly live, and I have 500 millisecond latency, then okay, maybe I'll switch over to Storm and just rip that out and add something back in. And I think that flexibility, especially when you're in kind of prototype mode, is pretty awesome.
Great, and for Tableau, the way we've approached this has been consistent for 11 years, right? We built a product from the ground up to be visual, easy, fast, and empowered subject experts to self-serve. And I think you'll hear that from all of us, that's a goal of new staff analytics, is to be this thing that empowers the people that know the data best, the subject experts, to actually create and have a conversation with their data and iterate and ebb and flow without having to go call someone to help you. And I came from a customer perspective. I was in fact one of Tableau's largest customers a couple of years ago. And this is the pain I lived. So the way that I'd explain it is through a story as it relates to that. I didn't buy Tableau for its visual prowess as a customer. I bought Tableau because I had 220 active projects with a team of 26 people, and I didn't have enough time in the day. The other thing is I had every technology on the planet that I connected to. And so I needed a consistent interface for people to be able to do this work. So our separator is we connect natively to 42 plus databases. And those range from Hadoop to NoSQL to text to you name it. We can get there. And if it has a SQL interface, we can connect via generic ODBC. And that was what appealed to me as a customer, is I could give my end customers, my business partners, an interface that was completely consistent. The experience was easy to learn. My adoption rate went through the roof, right? What took people weeks or months to learn was taking them hours or days. And we got better requirements. The business user could show you what they wanted to build rather than trying to explain it to you. And that ability is the game changer in big data, right? To become a data-driven company, you're not going to get there if the subject experts are one removed from the conversation. It doesn't work. It's human nature, right? The best example might be doctors in hospitals going to an IT guy and saying, write me a report on my patient, right? Who knows that data better than that doctor? And if you give him a tool that he can use and actually show you, or she can use, sorry for the ladies, but if you give the doctor a vehicle that they can use to do this themselves, they can get there much quicker than the translation that occurs in the traditional methods. So I think what's cool about this panel and open source and our competitors is we're shaking the market, right? Gartner last year changed the definition of BI, if you saw the Gartner report, and self-service is now fundamental to BI. Visualization is fundamental to BI. And that's a huge shift, and I think our competitors, us, everyone in this space makes it better. Hadoop, Spark, all of these things drive a better outcome for customers, and at the end of the day, that's why we do it.
Okay, so since we're Spark Meetup, let's kind of
Connected now to Spark. So the next question is, how does your solution integrate with Spark and function with Spark, and what's the best way to use Spark with your solution? So let's start the other way.
Okay. Well, ours is pretty straightforward. We have a connector, right? And that connector is designed to hide the complexity of the SQL development, to make it feel like every other experience we have. And so that's how we go at it. If you look at the major Hadoop distributions, we support Cloudera, Horton, Big Insights, Pivotal, and MapR. We have others that we support that are not named, but those are the named ones that we have tighter integration with. So we're going to continue to innovate and develop in this area. We think it's critical for customers and the market in general.
So I won't talk as much about the architecture. I think I already kind of laid out how, for this particular example, I had data flowing in over this live stream into Spark Streaming, and then going into a database, and then a front end pulling this database and being updated from there. And that was one of really, there's probably a ton of different ways to answer that problem of maybe using Spark. How do you then visualize data? You don't even necessarily need the database layer in the middle, but there are plenty of other options I could have chosen. I really think the role of Spark is something that at least I encounter every day, is that we're trying to answer analysis problems that are most of the time too complex for often SQL or SQL or any of the variants, Hive or Impala. And when we encounter those problems, they're often answered by writing code. And traditionally, for the last several years, our lab has been very Hadoop-based, writing MapReduce, Hadoop streaming, things like that. And we've grown up to the point where we know the other tools that are out there. We now know when MapReduce is maybe not the best tool for the job, and when it's just really slow. And Spark is kind of creeping up into that spot where we're just going to take over a lot of our Hadoop work, where just we have problems and questions that are just on relatively large data sets in the terabyte range, and the logic to answer that. There's a lot of different examples, but it's just something that probably can't be answered well by SQL. So this particular example I have visualized here, just calculating kind of a running average, was maybe even too simple. But as soon as it scales up to something more advanced than that, Spark is going to just play that huge role, especially when you get into something where you're running some type of machine learning model and you have maybe a trained model sitting in memory, an MLib or something, and scoring data coming in, and then the computation layer in the middle is, I think, with Spark answered perfectly.
So Platfora integrates with Spark in this facet that we call advanced analytic modules. So we believe, much like Ben was saying right here, that Spark is great for allowing a data scientist or a programmer to answer a question that a traditional SQL-like solution is not going to be able to answer out of the box, right? So you want to do a heteroscedastically consistent logistic regression. Normally, you're going to go to a SAS or an R, or you're going to write some custom code to do that kind of stuff, right? It's not going to be something that you're just going to write some select statement in SQL with. So Platfora is allowing a data scientist, someone who knows how to write Spark or Spark R or Spark SQL or any of the different pieces that are being integrated with Spark today, and inject that as an arbitrary transformation into Platfora that's then available for your data administrators to integrate it with their with the metadata how we're understanding the raw data that's in Hadoop, and then eventually exposing that to the business analyst to allow a business analyst who has no idea how to do a model. Maybe it's Keats model 1, 2, 3. They want to make sure that they keep that score in their data mart, rather than them having to call me and I'll have to write some code and run a job and load it into a database, and eventually they'll get access to it. Now they'll be able to present that at the GUI level where they can just select that as one of the elements that they want to include in their data mark. That's a big, huge, powerful thing, because your current data processing pipeline is multiple steps. It's I've got my raw data somewhere, and then I'm going to transform it somehow, and I'm going to load it into some system, and then I'm going to attach to it via some adapter, and then I'm going to visualize it with another tool. And every time you context switch between those different pieces, you have at least one individual that's got to talk to some other person to figure out how those things plug in, right? It'd be great if everybody knew every piece of technology in the world, but the reality is that's not practical, right? And I'm not going to go learn, I'm not going to go get my PhD in statistics to learn how to write some really complex scoring model, but I might understand that, a score above a certain threshold is something I need to pay attention to, and I want to include that in my modeling going forward. So, really great thing about Spark and the way it's enabling kind of a higher level abstraction of data processing over Hadoop than MapReduce really was, is that it's going to take the activity of data scientists out of people who can figure out how to program in MapReduce and bring it up to the level of the statisticians that are out there today, guys that know SAS or R or Python or those types of programming languages. And it's going to allow them to get the knowledge that's in their heads about how to model and score and find interesting insights in their data. And it's going to, and Platfora's thought is that they can abstract that in a Spark implementation that's relatively simple. And now with Platfora, they're going to be able to wrap that up and present that out as a product effectively that they're going to be able to share with the rest of their organization.
For us, we have many, I guess there's a lot of use cases around Spark. So I'm assuming, as you guys are in the meetup, you guys are kind of aware of the benefits of Spark, right? So it's really a unified execution framework. It's one-stop shop to do interactive exploration. You can do iterative machine learning algorithms. It has graph computation. So for us, as we kind of reviewed Spark, we've been working closely with the team at Databricks. What we wanted to do was kind of, I would say, threefold in terms of use cases for Spark. One is connectivity. So we do have a Spark SQL connector, and with that, that gives us connectivity to a lot of sources, whether it's the various Hadoop distributors and distributors and what you have, as well as all of the other things that are occurring in sort of a roadmap of Spark SQL and Spark Direction 2015. The other part is, the second part is, I would say, a performance booster. So in Zoom Data, we have this functionality called Sparkit. And really the way we've architected Zoom Data is to have two deployment options. One is kind of a full stack where we're shipped with Spark, and then you're able to kind of scale out Zoom Data. Or you can keep it very light. Our philosophy is data has a very heavy gravity, right? You want to kind of take the questions to the data. A lot of organizations are investing in building their data pipeline, so we wanted to kind of take advantage of that. So in Zoom Data, you can point to an external Spark cluster. And then with the Sparkit feature, what we give you the capability to do is point to flat files sitting in S3 or HDFS files, or you can actually select SQL queries against relational databases or tables, whether it's in Oracle, MySQL, Postgres, etc., and be able to actually use Zoom Data to Spark it, which essentially creates an RDD from that data, and then you have the sort of the in-memory speed access to it. And then the third use case in our architecture is with Spark being sort of the memory first setup with the spill to disk. I mean, you get performance, right? That's one of the attractive things about it. So what we've done is we've actually built our in-memory layer using Spark. And really in the traditional BI world, everyone's used to the word OLAP and OLAP cubes. What we've done is we've essentially rebuilt that in Spark, and we have a smart way of doing it. So you don't necessarily have to build your cube or warm it up ahead of time. It's kind of done for you, as I was showing in the demo. And then by leveraging Spark as sort of our in-memory layer, now we have flexibility of doing calculations on it. We have the flexibility to fuse data sets together. We also have the ability to have advanced analytics on it. So that's sort of leads to kind of where we're going on our roadmap. So right now in Zoom Data, you have the connectivity through Spark SQL, you have the ability to boost on SparkIt, you have the Zoom Data Cache leveraging Spark, and then in our next set of releases, you're going to actually have the ability to fuse data coming from a variety of sources and then doing calculations on top of it.
Thanks a lot. At this point, since you already kind of, Keith and Fazad pointed out like the advantages of Spark, like we have the question, like what would you like to see from Spark like in the future that would make your solution even better?
It's interesting starting with me because I don't have a lot of great answers for this. I think that this kind of goes back into the first answer for why I'm somewhat of an advocate for open source and building solutions that fit in multiple open source projects that fit together. It's kind of interesting working with Spark. I was talking with a couple other people. If you've worked with Spark for more than 6 months, you've already seen a couple major releases. I started working with it only about a year ago when it was back in the pre-1.0 era, and things were really buggy, and there was a lot of things that weren't working quite right. And each release has added a lot of new functionality. I think that gives us a big advantage that if you're working in prototype mode, you can easily just update your code and use some of the new features without a lot of additional work, which I know that's not always feasible for other cases. So in terms of what needs to be added to Spark for me to do my job better, I mean, honestly, there's not a lot. I think there's a lot of movement right now in adding, you go look at a lot of Spark examples and use cases, and here's how you use Spark, and it's always just text. And it's always kind of a letdown because, it looks really easy, and then you start building out your solution, and, it's always more complicated, and you're like, you made it look really easy because you're just reading in like CSV files, and you're never actually doing that. And I think their attitude until pretty recently has been, we're building the core, the kernel of Spark, and we leave kind of everything else up to you. And I think it's moving into this now that it's much more stable than it was 6 months ago. They're building additional layers just to make all those things you encounter, whether you're a data engineer or a data scientist or whatever your role is, that next level of features, Spark works, but now making it more and more usable, I think they're building in. And I mean, really, I can't really complain because I think it's fantastic already. But
And for us, it's probably two basic things, or one not so basic, but Spark SQL working in a Spark context rather than a Hive context would be a good one. Probably a bigger one for enterprises is Kerberos support, right? Because right now you have to go one-off to support Kerberos based on deployment, and it'd be nice if that was just part of the layer, right? So for us, those are probably the two big ones. We're working closely with Databricks, Simba as well. And so hopefully we'll bring some of that to bear, but that's what we'd like to see.
I do have one more. I'm going to cut back in. I'm going to jump in a second. One jumped in my head I wanted to say real quickly. Spark seemed, whenever you run into certain issues like actually deploying Spark on a cluster, one thing I found, this gets a little bit more down in the weeds and won't go too far into it, but Spark with Yarn and how it plays with MapReduce. You ask these questions like how is Spark going to play with other MapReduce jobs or with other users, and you have multiple Spark contexts open at the same time. Until somewhat recently, I think the answer's always been this, more of a theoretical, like, we're kind of assuming you have one user on one cluster running, and you're it's not very realistic of a scenario. And I've already noticed if you have a 100 node Hadoop cluster and you don't exactly know what you're doing, you spin up a Spark shell that's consuming the entire cluster, and you have hundreds of other users across a company that no one can do anything. MapReduce jobs just waiting in a queue because so getting more down in the weeds, you can there's multiple PRs out there for it's not really on the Spark side, it's more really with Yarn, but dynamic resizing of Yarn containers and just kind of even more advanced resource management so that you can have users running MapReduce jobs and it smartly interacts with Spark, whether you're running in kind of a Spark shell environment, whether it's through some other tool or whether you're just using Spark Submit to submit jars that are running, that they just play nicely together, because I think it's still really volatile that you're just going to get yelled at by all your system administrators by when you do anything. And so I foresee that getting better in the next few months.
So I didn't really have an opinion on this question, so I asked some of the folks at my headquarters, and then was I wasn't really happy with the responses, not because I didn't get great responses, it's just that I got a ton of responses and I can't remember them all now. The one that did stick in my head, so Platform has been around just long enough that Spark really didn't exist when we got started, so we built our own cache layer that's got an MPP scale out capability, which is great because it allows us to handle building data marts on petabyte scale data sources, right? But it also means that you've got effectively two caching layers, right? You've got the caching layer that's in Spark, you've got the caching layer that's in Platform, and so we would love to be able to kind of deprecate the in-memory component of Platform down to the Spark layer. But the thing that we're discovering as we're going into it is, so Spark's caching mechanism is really just one kind of an in-memory structure, right? And our in-memory structure is a lot different than the Spark in-memory structure, which would make for a lot of rework. And we would love to see a case where there were multiple in-memory kind of cache-like architectures that you could say that you want when you open up a Spark context. So we're multi-dimensional, so either pivoting around a set of aggregates in an OLAP style engine, or in an event series processing where we're pivoting around a timestamp in a series of events. We would love to see that same type of a context where you can have multiple types of in-memory contexts that aren't just the raw data that's been scanned off a disk, and as much of it can be stored in memory as possible, and then you're spilling off. We would love to see cases where you could say have an index context, or an event series context, or a graph context that was going to have changed the behavior of the in-memory caching from Spark.
I think for us, so as a younger company, we're kind of used to early stage technologies. We ourselves know there's many things in terms of gaps that we need to close on. As a tool that's meant for the business user and looking at enterprise use cases and wanting to have sort of like that large scale deployment, I think it's important to be able to support many users concurrently, having the application be highly available, having a failover strategy. Security obviously is important as well. So I think for us, the context sharing, as was mentioned earlier, is an area that we've actually started to build a lot of our code base on it, and allow the capability as we kind of grow the user base to be able to horizontally scale our application and actually take advantage as kind of a one view into Spark. I think Spark SQL came at a perfect time because we were kind of looking into Shark and looking at some of the issues we saw. Then we saw the schema RDB and Spark SQL, so that was great timing. Looking at the 2015 vision of Spark, we think there's a lot of great things that are being built by the community. I think the advantage of having such an active project brings a lot of benefits from a lot of different areas that we're seeing. And then for the people on the audience that are wanting to get more of that developer feel, we do have our VP of Engineering, Jorge, who's here, as well as Hung and Hari, who also get to work with Spark every day at the code level. So feel free, if you have any specific questions, to kind of reach out to those guys. I'll point them out after the panel discussions today.
Thank you very much. Since we're already looking into the future, I'm wondering, what do you see as the main trends in BI and visualization in the next 6 to 12 months?